Alright guys, so AP Physics 1, gravitational fields. This is the problem we have. Right, so something that we should know before even going into gravitational fields are, those two Newton laws that I've been saying. So a planet of radius r and mass m has a moon, and this big oval is pretty much the path that moon is traveling on. And then this little gray circle is, the planet. So now these are the 3 points, and we know that this planet has a radius of 1r. So now determine the gravitational field strength at point B, GB, in terms of gravitational field at point C, GC. So big thing we're trying to do is we're trying to find GB. So before we even get to any of that, what we need to do is we need to use this formula right? Just get this general formula going, right? And we all know that this equals G over FG over M. Substitute FG with this, Newton's universal law of gravitational. What are we gonna get? G M2 R squared all over M. And we can just say M1 or mass of the moon. Sure, let's just call it M1 mass of the moon. Okay, so the mass of the moon cancels out. And what we're left with ultimately is G equals G M2 R squared. M2 R squared. Okay, M2 R squared. Now, I'm not sure if that's the mass of the moon, but all we know is that one of the masses cancels out, and that's really all we care about. So now we are gonna move on to the next thing. Okay, so now that we've gotten this, now we can easily get the other things we need. Okay, wait, I was kind of wrong. So this thing is the moon. Okay, whatever. Still doesn't matter. Okay, so what we're now gonna do is, continue finding the gravity. Now we need to find GC as well as GB, but first let's find GC. So what do we know about GC? We know that it's got this 5R, but we know that there's a 1R right here as well. So together that makes 6R. So here's what we're gonna do. 6. So let's just substitute our 6R in place of this R squared. And then let's just put our GM2 or whatever. Okay, then next thing we need to do is find GB, right? Okay, GB. What is that? Okay, so GB is 2R plus the 1R, right? That creates 3R, right? And the 1R is coming from the planets, if you guys remember. Or the moon. We add that too. Okay, so here's what we're going to end up getting. Okay, so this is what we have, right? And in order to determine the GB in terms of point C, so pretty easy stuff. You're just going to put GB over GC, right, to determine the gravitational field strength at point B, GB in terms of the gravitational point at point GC or whatever. Okay, so here's what's going to happen. GB, 9R squared, GM2. Okay, so GC is going to be 36R squared, GM2. Okay, So we all know that this is just going to be the reciprocal, right? So essentially what's going to end up happening is that this denominator is going to come up. It's going to be something like 36 r squared all over gm2. The notation is just going to cancel out. So it's the r squared. All we're going to be left with, and then we're just going to be left with 36 divided by 9, which is 4. And then remember this GB over GC, we can just write down GB, multiply over the GC. That's our answer right there. See, it was a very complex looking problem. However, we broke it down, and at the end of the day, all it was an application of Newton's law of gravitational, both of them. And that's our answer.